I am Dr. P. Saranya, Assistant Professor, PG and Research Department of Mathematics, Sri Sharada College for Women, Autonomous, Salem 16. In this video, we are going to see the topic about sphere. First, we see the definition for sphere. A sphere is defined as the locus of a point which moves such that its distance from a fixed point is constant. The constant distance is known as the radius of the sphere. The fixed point is called the center of the sphere. Next topic, we see the equation of a sphere. Various forms of the equation of the sphere have been described here. First, we see the standard form of the equation of sphere. Consider a sphere with radius r and center as origin O of 0, 0, 0 with a point P of x, y, z on its surface. Then, by the definition of the sphere, OP equal to radius of the sphere or here x minus 0 square plus y minus 0 the whole square plus z minus 0 the whole square equal to r square. From this we get x square plus y square plus z square equal to r square. This is known as the standard form of the equation of the sphere. The figure is given below. Next we see the central form of the equation of a sphere. Let P of x, y, z be any point on the sphere with center C of a, b, c and radius r which is from center to the point P of x, y, z. Then Cp equal to radius of the sphere, that is small r, x minus a the whole square plus y minus b the whole square plus z minus c the whole square equal to r square. This is considered as an equation number 2. The above equation is the central form of the sphere. Next we see general form of the equation of sphere. By expanding equation 2, we get x square plus y square plus z square minus 2ax minus 2by minus 2cz plus a square plus b square plus c square minus r square equal to 0. That is, you have to expand the equation of x minus a the whole square plus y minus b the whole square plus z minus c the whole square equal to r square, which we will get finally x square plus y square plus z square minus 2ax minus 2by minus 2cz plus a square plus b square plus c square minus r square equal to 0. On substituting a equal to minus u, b equal to minus v, c equal to minus w, d equal to a square plus b square plus c square minus r square in the above equation. Finally, we get x square plus y square plus z square. Here you have to replace a equal to minus u, that is plus 2ux plus 2by plus 2wz plus d equal to 0. Consider this is an equation number 3. The equation 3 represents the general form of the sphere. It possesses all the characteristics of the sphere. Next we see the diameter form of the equation of a sphere. Let us consider a diameter xy of a sphere having two endpoints x of a1, b1, c1 and y of a2, b2, c2. Also, let p of x, y, z. Kindly see the below figure. Be any point on the surface of the sphere such that xp, which is perpendicular to yp, that is angle of xpy which is equal to 90 degree. But the direction cosines of xp are proportional to x minus a1, y minus b1, z minus c1. And the direction cosines of yp are proportional to x minus a2, y minus b2, z minus c2. Therefore, x minus a1, x minus a2 plus y minus b1, y minus b2 plus z minus c1, z minus c2 equal to 0. This represents the equation of the sphere in diameter form. Next, we see the radius and center of the sphere. Let us consider the two different cases of the general equation of a sphere. First one, when the general equation of the sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. That is, the coordinates of center is given by minus u minus v minus w, and the radius will be square root of u square plus v square plus w square minus d. In case 2, when the general equation of the sphere is given by ax square plus ay square plus az square plus 2ux plus 2vy plus 2wz plus d equal to 0. Here, the coordinates of center is given by minus u by a, comma minus v by a, comma minus w by a. The radius will be root of u square plus v square plus w square minus d divided by a. Rules for writing down the center and radius of a sphere. First one, write down the equation of the sphere such that the coefficients of x square, y square and z square are each equal to 1 and right hand side is equal to 0. That is, if all the equal coefficients of x square, y square and z square are different from 1, then we need to divide throughout by the coefficient of x square or y square or z square. Step 2. After that, compare these equation with x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. Third one. Now, write the coordinates of the center as minus u, comma minus v, comma minus w. That is, minus 1 by 2 coefficient of x, comma minus 1 by 2 coefficient of y, comma minus 1 by 2 coefficient of z. And the radius is square root of u square plus v square plus w square minus d. Next, we see one example problem for the sphere. A point moves such that the sum of the squares of its distance from the 6 faces of a cube is a constant. Prove that its locus will be a sphere. Solution. Let us consider the center of the cube as origin O of 0, 0, 0. Also, let the three mutually perpendicular lines through the center and parallel to the edge as axis. If the length of each edge equal to 2a, then the equation of the 6 faces are x equal to plus or minus a, comma y equal to plus or minus a, comma z equal to plus or minus a. Let x1, y1, z1 be the moving point, then x1 minus a by 1 the whole square plus x1 plus a by 1 the whole square plus y1 minus a by 1 the whole square plus y1 plus a by 1 the whole square plus z1 minus a by 1 the whole square plus z1 plus a by 1 the whole square equal to constant, which is equal to 2k square. Therefore, 2x1 square plus 2y1 square plus 2z1 square plus 6a square equal to 2k square, which implies x1 square plus y1 square plus z1 square, which is equal to k square minus 3a square. Thus, the locus of x1, y1, z1 is x square plus y square plus z square equal to k square minus 3a square, which is a sphere. Next, we see sphere passing through 4 given points. The general equation of a sphere is x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d, which is equal to 0, contains 4 constants u, V, W and D. In order to find out the equation of a sphere, we need to determine the values of the four constants U, V, W and D. The values of these four constants can determine when we have four descending points through which the sphere is passing. Thus, a sphere can be found to pass through any four points that are non-coplanar. Let us assume that the four descending non-coplanar points as x1, y1, z1, x2, y2, z2, x3, y3, z3, x4, y4, z4, through which the sphere represented by equation 4 is passing. As the sphere in equation 4 is passing through the four given points, we get x1 square plus y1 square plus z1 square plus 2ux1 plus 2vy1 plus 2wz1 plus d equal to 0, which is equation number 5. x2 square plus y2 square plus z2 square plus 2ux2 plus 2vy2 plus 2wz2 plus d equal to 0, which is equation number 6. x cube square plus y cube square x3 square plus y3 square plus z3 square plus 2ux3 plus 2vy3 plus 2wz3 plus d equal to 0, which is equation number 7. x4 square plus y4 square plus z4 square plus 2ux4 plus 2vy4 plus 2wz4 plus d equal to 0, which is equation number 8. By eliminating the variables u, v, w and d from equations 1 to 8, we get determinant of x square plus y square plus z square, x, y, z 1. x1 square plus y1 square plus z1 square, x1, y1, z1 1. x2 square plus y2 square plus z2 square, x2, y2, z2 1. x3 square plus y3 square plus z3 square, x3, y3, z3 1. x4 square plus y4 square plus z4 square, x4, y4, z4 1. This determinant value which is equal to 0. This gives the required equation of the sphere in determinant form. Next we see one example problem. A sphere of constant radius 2k passes through the origin and meets the axis in A, B, C. Show that the locus of the centroid of the tetrahedron OABC is the sphere x square plus y square plus z square equal to k square. Solution. Let the coordinates of the points capital A, capital B, capital C be A, 0, 0, 0, B, 0 and 0, 0, C respectively. The equation of sphere OABC is x square plus y square plus z square minus ax minus by minus cz equal to 0. Given radius of this sphere is equal to 2k. So we have to substitute in that a square plus b square plus c square equal to 4 2k square, which is equal to 16k square. That is equation number 1. Let x, y, z be the coordinates of the centroid of the tetrahedron OABC. Then x equal to a by 4, y equal to b by 4, z equal to c by 4. From this we get a equal to 4x, b equal to 4y, c equal to 4z. By eliminating a, b, c from equation 1, the required locus is x square plus y square plus z square, which is equal to k square. From this, check your progress. Define radius of a sphere and then what is the standard form of the equation of a sphere? Thank you.